the humble game console HDMI replacement. Very, very common. This is a PS5 motherboard. You might get it on an Xbox One X or Xbox Series X or S or PS4, but it's really the most easy to damage thing, right? When you have an HDMI port on here, you have a lot of leverage, and generally the ports really aren't that well supported on these consoles. I'm just gonna go through briefly how we do these. There's probably some other ways to do these too. I'm taking off the nozzle on my hot air gun, just like this. Want as much airflow as possible. These boards have a lot of thermal mass and really soak up heat, so I mean, you kind of work to, mine gets kind of stuck in the little delatch thing there. Okay, we're gonna use them in a second. First thing I want to do is just add leaded solder to the pins. Frankly, on this one, we probably could just heat it from the backside and just have the thing fall off as is. I would say it is good practice to still just add lower melt lead-free solder to these joints. Avoid pulling any pads essentially. So sometimes you might have these and maybe some of the contact pads are kind of loose, and if you might just heat it with the leaded solder, and kind of when the port falls away, we're going to heat it kind of from the backside and let the port fall off in a second. But just having that lower melting point solder on this just kind of makes that not happen. I'm going to turn up my fume extractor a little bit. And it doesn't really even need to look pretty on this. We're not setting the new port. We just want to get leaded solder on these pads. We're going to be mindful of that little capacitor there on the lower right. So I'm just going to kind of drag into the plastic of the port pretty much so I don't hit that little capacitor. Oh, I don't want that touching. And really, you can just kind of have a big old glob on the pins like this, and that will really get your average melting temperature of these joints down. If this really bothers you, you can always wick them after, but we're going to take this port off so we don't really care. And then we're going to want to add leaded solder to the back. Now, just with like a micro pencil or something, maybe if you had a really big iron head, you could just heat these. I honestly pretty much just use the micro pencil for most everything. I'm going to get some solder globs just kind of on there. We can see this is kind of like, right, I don't have enough thermal mass on my micro pencil to actually melt this whole through hole joint, so I'm gonna just get some solder on top of all of these, and then I'm gonna use some supplemental heat from the hot air gun to help out and just kind of get this so the leaded solder mixes in with the existing lead free, and we can get the melting temperature of these joints down. Something like this. Kind of preheating the board here. Okay, so this is pretty ready. I wonder if the overhead cam will kind of show what I'm doing. So, you have your table, and use the hanging this kind of over the table method of getting these off. But I essentially just have the port hanging over the table, so when I heat it, it's just going to fall away into the void. So now I'm just applying this sort of top heat. I'm actually going to move my microscope because I do just want this kind of pointed straight down. Kind of sit, you know, think about life. And good news is, with the new solder that we have on there, our Kester 3773, these joints will actually be stronger than what's on here. Hope this won't break so easily. So you can give them a little love tap through tweezers, just really lightly. This should just sort of fall away in a second. Any second now. Oh, you know what? I normally do this at my hot, it was at 430. I would just put your hot air station to the hottest it goes. So mine's 500, 120 airflow. It's a quick 861 DW. These boards just really soak up a bunch of heat, so just get it nice and toasty. It'll still take a while even when you're at 500. I guess once I record this, I'll actually see how long. But it's probably almost a minute of putting hot air, even at max heat. So it takes a while, and I can see it's kind of loose. And then I just gave it a little tap there because the pins are. It's gonna the through hole ground pins will kind of leverage themselves against the board. So the reason I do a little tap like this is to get it to, you know, unlock itself and just fall straight out. Your port on the floor is gonna be hot. Oh, I'm trying my best to grab it with my tweezers. I'll let this fall on your privates or something. That would be you'd have a bad time. Okay, so now we're going to prep this area. I'm actually gonna wait for my hot air to get cooled down a little. Now I want to put my nozzle back on. So we're going to use that. Okay, I got that back on. I like to just kind of do this from the top side. These can be kind of large, awkward boards to work on. And you just sort of, you know, generally, like same thing if we're doing, you know, an Xbox HDMI port, we're gonna kind of be doing the same sort of thing, or really any HDMI port, you're gonna wick off the through hole joints and the pads and add, we're gonna add new solder essentially to the pins that we're using. We're getting some solder wick. Use Goot wick. Does work well, just like the name implies. Now for the little pins, just iron will be fine. Like so. For these larger through hole joints, just use hot air. Going to 430, 120 airflow, and I'm gonna kind of get probably basically a piece of wick for each side. It's fine if you need to use one for each. I very well might. We'll see. But generally, I'm basically gonna grab, like, you know, 2 or 3 pieces, something like that. I'm actually gonna get that in there, let that solidify and get some more flux because it's not really doing what I want it to. Get some more flux on there. I'm just gonna get a new piece of wick. This one's kind of chewed up. You don't really need a super long piece, so just go ahead and get individual ones for each through hole. So you'll probably need it. Just cut a few pieces. It costs, you know, less than a penny. But essentially, right, you're heating the joint, and you're just gonna kind of like stuff the solder wick through just to get everything cleaned out. I kind of feel like I had a little bit left in this one, so I'm just gonna get that in there. Okay, grab another piece. It's good, just burn your hand a little. Longer tweezers would have been a good idea for me right here, but I had these ones next to me. You see, it gets it really easy. I think a lot of people will struggle with this because they're just trying to do it with an iron, which really, you know, can be difficult for through-hole stuff. So, especially on a board like this, it's just so much thermal mass. It just really soaks up heat. I feel like at this point there is kind of two ways to go about this. Some people like to just put the port, you know, they put it on and they solder all the pins by hand. There was a time when I would just do that too. I feel like this little capacitor, if this didn't have this little capacitor, I would just do that. But it does, and it's kind of annoying to work around, even with a micro pencil. So I do prefer just to set these with hot air. For the Xbox ports in particular, they will have little under the connector kind of ground joints on the front side of the port like this. So on those, I also do this. I'm going to put leaded solder on the pads. Specifically for the Xbox ports, I will also take a Dremel bit and essentially rough up the ground legs on the port. I feel like for whatever reason the ports that are available for those really don't bond well. I don't have that issue on these PS5 ports, but you know, I'll take a rotary tool basically and scrape the edges on them on an Xbox port. And what I still am going to do on this, it's also be a tip for, you know, like a Nintendo Switch USB-C port, or you know, something where you're using hot air and you need to set it on pins. We're just going to add a little bit of solder to all of the pins under here. It's going to kind of make your life easier just for setting this with hot air. So we're going to be using a lower temperature. So I just kind of, you know, you don't need to go too crazy. And go like this, so I'll bridge every single line. I'm gonna add more flux and we'll clear those bridges. I'm impatient, so I just did this. But I mean, you could essentially, you know, just add solder to each little pin individually. I'm gonna go like this. Get some more flux on there. Okay, something like that. You just want some solder on all of those pins. For this one, I'm going to do a little bit too much. And this is just going to make this set easier. So then, well, let's go ahead and just clean off the area, and then we'll add a little bit of new flux on there so we don't have such a mess. really some heat would be a good idea. And go to 140 now. Let's just kind of soften up all this flux. Okay, so let's get some new flux on there. Don't need a lot. And then I'm gonna face this away from me so I can see more better my actual pins. And I do to try to get this as back as possible. I'm gonna go to 350, 120 airflow. We can see all of those pins go, and I'm gonna get this back. Everything's melted. I'm gonna add some more flux on this. We can see all those set really, really nicely like this, and we don't have to worry about getting our, you know, iron in between this connector and this capacitor. And a lower temperature like this, you're not gonna melt you know, the plastic on the port. So I just like to get this as back as possible like this, hot air, let it cool down, and then we're going to add solder to the ground legs and then clean it up and put it back together, basically, and just make sure it works. Okay. Should be cool enough. And just the, you know, that connection on the pins is going to be enough to hold it. For heating these through-hole joints, kind of like how when we added leaded solder to them before, I'm going to use some supplemental heat from the hot air gun. Because even now, just with strictly leaded solder, the micro pencil is just not going to be enough heat. If you just have a bigger iron too, that should work fine. I actually do have a bigger iron, but I need to replace the tip, and I'm just doing this for right now, which is fine. See, and like this is why, if you don't have enough, or if you just have like a really bad soldering iron, like let's say a normal size one, and it just doesn't deliver enough heat on these sort of joints, even with a big iron, these boards can be really just soaking up a bunch of heat. You know, like this right here, what we're looking at is not a good strong connection. We want the solder to go down the whole shank of this post and just, you know, be filling up that through hole connection fully. So I'm going to use the iron and that same like 345. We don't going to go too crazy with the temperature, and I'm just going to point it directly at it while I have my iron on it. And what we want to see is that sort of, you know, flow down behavior for the joint like that. That's what we want our pads to look like, and we'll do that on all of them. Something like that. And this will hold a lot better than it does from the factory, because the solder we're using makes a stronger connection. I also like to go ahead and just add a little bit on the top side ground legs as well. I guess you could do this before you flip it over too, that's fine. Doesn't really matter. So same sort of thing here. On the Xbox boards, it's kind of harder to add solder from the top side. Do that on the other side. Oh, little flux. Where are you? There you are. Hey. Something like that. A little bit of extra support on the legs. I'd say it's always a good idea just to double check that all of your pins are still making a nice connection, and they are indeed. Very nice. Q-tip alcohol. 140 Celsius on the hot air gun. Soften up the flux. This has this sort of like exposed kind of copper stuff in here. It's going to get basically stained from the high heat of removing the port, and the flux does not matter. Kind of looks fun. It's like a patinaed copper, something like that. Word, rusted copper, stained. Oh well. We're going to clean it off. We just don't want all this flux residue on here because it's, you know, sticky and collects dust and would maybe cause corrosion over time, so we want it cleaned up as much as we can. I'm actually going to get in here with a trick from Chris B, formerly Shiny Computers. You got like Mr. Clean Magic Eraser and some acetone. It works really, really well for cleaning off flux on the board. Or you can also get, there is just like, you know, purpose-made flux removal stuff, which is basically just acetone, some other stuff. But you know, nail polish remover, basically acetone, and magic eraser, whatever kind of sponge the magic. It's not. I think you can just buy the sponge sort of generically, you know, from like China or whatever. But it is basically that type of spongy material in a Mr. Clean. Registered trademark, Mr. Clean Magic Eraser. This is a patented technique from Chris, the great Chris, a collector of vintage Macs and a gentleman. Actually need to go grab another magic eraser. We'll go grab that really quick. It says right on the box, 40% less scrubbing. I basically just tear off a little piece of this stuff. Acetone. I'm putting onto it just a bit. Nothing crazy. I just kind of just dab it on there. This is really quite good at getting flux residue off. I'll do that on the top side as well. I'm just using the same little piece of sponge. This is nice too. It's very soft, so it can kind of really form into like little crevices and stuff pretty nicely. That's quite clean. We'll get this back together now and test it. I think we'll be okay. I guess other basic thing, if you got anything with liquid metal, just put some Kapton tape or something over the heat spreader so you're not getting liquid metal over a bunch of stuff. That would be not fun. This stuff's very annoying to clean off of a board if you do get it on there. Think about is like those newer Asus ROG machines. I probably had 2 or 3 of those brought in where someone opened it trying to repaste it for some reason, and they just kind of got liquid metal all over their board. It's generally no bueno. Shorting a bunch of stuff around the CP is generally not good. So yeah, we'll get this back together and test it, and we'll be back then.
What a terrible liar I am. The end of that last recording for this HDMI port game consoling rundown was a few weeks ago, and all my cameras, they're like, I have them like screwed into mounts and stuff like that, and I don't really have a tester monitor right here. So we have a little tester monitor that I just have up front. It's like a little mini monitor that was like, you know, 80 bucks or something. I fixed some other PS5 today. So tell you what, I'll show a picture of a PS5 that I fixed today. As you can see, we do fix HDMI ports, and the one in my video did work. I promise. I pinky promise. That's pretty much it. You know, game console, PS5, Xbox, USB-C port on a Nintendo Switch. It's all pretty similar stuff. I think my main tip that I don't really see a lot of people do is adding that extra solder on the bottom of the contact pins. I think really helps a lot when you're setting them with hot air, and then you don't have to deal with the little filtering capacitor, especially on the PS5, the little filtering cap around the HDMI kind of makes it weird. And on the Xboxes, there's those ground pads on the outer section of it, so you do kind of want to set those with top heat on it. That's really the only way to get those to bond. You can't really get in there with an iron. So on the Xbox port specifically, we do take a Dremel and actually rough up the ground legs, because for whatever reason, most of the replacement HDMI ports for the Xboxes do not really seem to bond that well with solder. You rough them up and they make a very good, strong connection that that lasts a long time. So hopefully this helps someone fix game console HDMI ports more better, because it's a really common issue. It's easy to break, and people pick up the console, or their kids knock it over, or the dog eats the PlayStation, or you know, whatever may happen. But it's a very common issue. Something you'd get a lot of. It's good to know how to fix. So hopefully this helps someone, and we will see you in the next repair thing video that ends up in here. Halloween's coming up, so I hope everyone has a great Halloween and whatever other holidays you might be celebrating.